Everyone good. Section 8.4, multiply and divide rational expressions. Can I go?
Yes.
Alright, here we go. Simplifying rational expressions. So I'll give you a second to write these down. But the first thing that we need to know how to do is simplify rational expressions. The bottom. Okay, so in order to simplify a rational expression, we need to first simplify the top and simplify the bottom. So, whoa. Everything got weird. Okay, so I'm going to factor the top, factor the bottom. 15, when I factor that, is going to be 3 times 5. 65, when I factor that, I think is 13 times 5. You can check me, but I think that's right. So I have 3 times 5 divided by 13 times 5. And right here, I know that 5 divided by 5 is just
1, sir.
It's just 1, so the 5's go away, and I'm left with just 3 divided by 13.
It looks like dollar sign.
Next one, same thing. I've got to factor first. Oh, look, I can't factor this any further. Well, maybe I could factor the 6. But another approach is to look at 3 over 6 and just simplify that as a fraction in and of itself. So I'm looking at the 3, I'm looking at the 6. What can I take out of each one? Well, a 3, and I'll be left with a 2, right? So on the bottom, if this simplifies to not 3 over 6, but 1 over 2, I think I'll have a 2 on the bottom. I'm not going to write the 1 on top. I hope that's okay.
That's okay.
And then I look at the x's. Well, I have 3 x's on top, and I have 4 on the bottom. So I think I can cancel all of them from the top, and I'll be left with just 1 x on the bottom. So this will be just a 1 on top. That's all I have left on top, and y times x. Similar approach, I look at, first of all, I have to factor. Oh, look, I've already factored. How convenient. And then I see that an x plus 3 and an x plus 3 will cancel out, and I'm left with 4 divided by x minus 5. I don't think I can simplify anything further there. Do you agree? Oh, can I simplify 4 divided by x minus 4 at all? If these two things are being subtracted or added, then I can't cancel them out. Right. So another way to think about it is, think of x minus 4 as one factor in and of itself. And then it's a little bit easier to look at. I've got a 4 on top, and then I've got this x minus 4 on the bottom. Those are not the same thing, so I can't cancel. Okay? If it was multiplied, then I'd be golden. But I'm adding and subtracting. What's that, Gavin? I'll give you a second to write it down here. But I'm going to approach it the same way. The last ones were pretty much all factored for us, except that first one. This one, however, I've got to factor it first before I go trying to cancel things. We're getting really good at this now, so factoring the top, that's going to factor into...
-3 and... no, I don't know.
You're close. Positive 3. Is that right?
Yeah.
Yep, okay. And then that bottom thing, I'm going to claim that's a special... We learned like a special rule back in maybe second trimester. This factors into x minus 3 and x plus 3. And if you don't believe me, FOIL it back out, and you get x squared minus 3x plus 3x.
I did not know that.
Minus 9. And look what happens to the middle terms. It's magical. They go away. I get x squared minus 9. Right, so now that I'm factored, x plus 3 cancels out. So in another color for your learning convenience, we see here that x plus 3 goes away. And I'm left with just x minus 5 over x minus 3. And my question for you is, can I cancel the x's? Are they being multiplied, or are they being subtracted or added?
I'll tell you what you can.
They're being subtracted or added, so I cannot cancel the x's. I'm done. If you want, leave it in parentheses to emphasize that x minus 5 is one thing. The x minus 3 is one thing. They are not the same. I cannot cancel. Cross. So what this becomes is 5x squared. 5x squared times 6xy cubed. All divided by 2xy squared times 10y. Occasionally you will see me say, hey, let's use the magic eraser and just make this one solid line here. And that's the same thing. Now, let's simplify that thing on top first. 5 times 6, I think, is 30. X squared times x is x cubed, and y cubed I can't change. Divided by 2 times 10 is 20. X, oh, well, that's just x. And then y squared times y is y cubed, I believe. Looks like the y cubes go away. Oh, how nice. looks like also 30 over 20. Don't I end up with 3 over 2? How you liking that purple highlighting? Pretty good? Okay, all right.
It's very cool.
Now I'm going to have one x go away here on the bottom, and then I'll be left with 2 of them up here at the top. Whoa.
Yeah, I think you should write with a highlight.
Yeah, I'm not going to. So let's rewrite this as 3 over 2. Oh, excuse me, 3x divided by 2. You could write that as 3 over 2x or 1.5x, or I would just leave it as 3x divided by 2.
Wait, are there 2 x?
Thank you. X squared.
Everybody
Didn't
got
mean to
pretty
freak
upset
you
about
out
that.
there. So, this thing. Now, there's a couple options here. The first thing I can do is actually multiply these things out. I'm going to end up with like 5 terms on top and 5 terms on the bottom. That's going to be a mess. Or 4 terms on the bottom, maybe. What we should do first is factor. Okay, so the first thing I'm going to do is try and factor the numerator of the first fraction. Okay, let's factor this. And I look here and I see that this has a 3x in it, and the second term also has a 3x in it, so I'm going to factor the 3x out. Lose the phones, please. That would be what I'm referring to. So I'll have 3x times, when I take a 3x out of a 3x, that leaves me with 1. And then when I take a 3x out of a 3x squared, I'm left with just x, so minus x. X squared plus 4x minus 5 factors into x plus 5
X minus.
and x minus 1. Okay. X squared plus x minus 20, that simplifies to x, or excuse me, that factors into x plus 5 and what, x minus 4? Oh, I'm running out of space. X minus 4.
That's 12.
Not bad. Divided by 3x doesn't factor. Okay, now let's go through and cancel stuff. First, I'll deal with the 3x. It looks like I've got a 3x on top as a factor and a 3x on the bottom. It's all being multiplied, so the 3x's will go away. How magical. Now, I go to the 1 minus x divided by the x minus 1. This freaks me right out. I'm going to skip it and come back. I've got an x plus 5 and an x plus 5, so I think I can cancel those.
Cross multiple.
And then I've got an x minus 4, and that's it. So I'm going to leave that alone. Now I'm going to go back and deal with this 1 minus x.
I know what you can do.
Divided by x minus 1. They look a lot alike, but are they the same?
No, they're not.
No, they're not, right? If they were the same, we would put a 1, right? Yeah, exactly. But since they're really close, but except for opposite signs, I've got a positive x and a negative x and a positive 1 and a negative 1. They cancel out to give me, instead of 1, a negative 1. Okay? So this will simplify to be negative 1 times x minus 4. I have no denominator. We canceled out everything from the denominator. Actually, negative x plus 4.
Sir?
Yeah, I can put it over 1, right? So if I have this x squared plus 3x divided by... Oh, yellow's a bad color. If I have this x squared plus 3x plus 9, I can put that over 1. That makes it a fraction. That's really handy because I can rewrite this then as x plus 2 times x squared plus 3x plus 9, that's the numerators, divided by whatever was on the bottom, x cubed minus 27.
I get it.
All right, once I've done that, I've made that first step, I can go through and then try and factor everything. I go to the first thing, x plus 2, I can't factor it. X plus 2 is as factored as possible. I go to x squared plus 3x plus 9. You guys could go through and guess and check for a little while. You would find that that thing doesn't factor either. So then I go down to the denominator, x cubed minus 27, and that's where I've got something that factors, and that's where we're going to need the formula. So take a second right now. You probably have those formulas from second trimester somewhere, but you might want them written down again. These are perfect cube binomial formulas. Next, we're going to deal with x cubed minus 27. All right, and I'm going to claim that I can rewrite x cubed minus 27. I can rewrite that as x cubed minus 3 cubed. Do you agree with that? This looks a lot like a cubed minus b cubed, where instead of a, I have x, instead of b, I have 3. So I think I can use this formula up here, this a cubed minus b cubed formula, to factor this perfect cube binomial. All right? So, all I'm going to do is simply follow the rule. In place of A, I have x's. In place of b's, I have 3's. So, I start off, changes to a minus b. All right? Well, that's going to be x
Minus 3.
minus 3. So, x minus 3. Questions on the first? I'm going to once again plug in a and b, which is x and 3. So, I'll have x squared minus ab. Well, that's just 3 times x. Excuse me, plus. Right? Yeah, plus b squared. Well, that's 3 squared. And that's the fully factored form. So here's what I claim. The thing in green here, the big mess, is equal to the thing in blue. So I'm going to substitute it in. I'm going to change this to be x plus 2 on top times x squared plus 3x plus 9 divided by x minus 3 times x squared plus 3x plus 9. And look what magically happens.
X minus 1.
X squared plus 3x plus 9 cancels out. How lovely. And I'm left with just x plus 2 divided by x minus 3.
Wow.
I'm not going to rewrite it because I'm out of room, but your answer is just x plus 2 divided by x minus 3. Can you cancel the x's here?
No. You can't because there's the minus and the plus.
They're being added right here and subtracted here, so I can't cancel the
What is
x's.
just multiplication and division?
I'm going to change this. I'm going to make this 7x over 2x minus 10. I'm going to multiply now times x squared minus 11x plus 30 divided by x squared minus 6x.
Why did you do that?
Use my magic eraser, and I'm going to make this. Oh, look at that. I better use parentheses here. But it becomes a multiplication problem. And now, I've got to go through just like I would any other multiplication problem, and I've got to factor everything. So, on top, I can't factor 7x. I'm going to leave it alone.
Right.
Now, I'm going to factor this x squared minus 11x plus 30. That's going to factor into, and you can check me, but I think it's going to be x in front, and then, what is it going to be, 6, minus 6 and minus 5?
Yep.
Alright, and then divided by 2x minus 10. I think there's a 2 in each term here. I'm going to factor that 2 out in front. Alright, so this becomes 2 times x minus 5. And then I look at the denominator here, and this is going to become, let's see, I've got an x in each term, so I can take an x out. So let's make this x times x minus 6. So sorry for the Michigan colors, I apologize. Yes, I think I can.
I'm sure if you look hard enough.
Well, you're right. And here we go. I have an x. Notice first that I've got a bunch of things on top being multiplied and a bunch of stuff on the bottom being multiplied. So I think I'm okay to cancel a lot of stuff here. I'm going to cancel the x's first. Whoa.
I hate school.
Cancel the x's. I'm going to cancel. I'm going to cancel the x minus 6's. And I'm going to cancel the x minus 5. Once all that stuff is gone, I'm left with what?
7 over 2.
7 over 2.
That's a big waste of that.
I'm going to write this over 1. So let's go with red here. I'm going to write that over 1, and it becomes a fraction. And I just learned in the last slide that that's the same as multiplying by the reciprocal, or flipping it and multiplying. So this actually becomes 6x squared plus x minus 15 divided by 4x squared times 1 over 3x squared plus 5x. Alright, so that's the setup for this one. I'm not going to take the time and go and finish this one, but that's how you should start. And then we approach it the same way. Factor it and cancel.
Wait. Can you finish our problem?
Oh, yep, hold on. I will finish the problem, yes, but first here's your assignment.